In this video, we show the LOGEST exponential regression and Taylor-Maclaurin series sum expansion of growth and decay. This is the growth and the decay and the Taylor-Maclaurin series sum expansion. We begin with the growth. So this is equal to array formula exponent of the x values. That's for the growth. And for the decay, which is equal to array formula exponent of the x negative x values. Negative x. Because our b1 is negative 1. Here our b1 is positive, our b1 is negative. And we'll chart this. Insert chart, a scatter chart. We'll use this scatter chart. Scatter chart. And our trend line will be exponential. Exponential. And show the equation. And we'll put this on the left. So we'll put this on the left and enlarge it. We'll make it say 14 or 16. 16 will be better. And that's what we have for now. And I think we have one more. We enlarge the points. So series, the circle will be, let's say, 14. Just to emphasize. So that's the point. Next, we generate the we calculate this using logest. So this is equal to logest. These coefficients of the exponential, the trend line, logest data y. This is for the decay, and data x. So in the decay, b0 is 1, while b1 will be the logarithm of this. So this is equal to ln of exponent b1. And it's negative 1, which is negative 1. Next, the regression of the growth. So this is logest exponential regression of the growth, data y, and data x. So here we have 1, which is our b0. That's for the growth. And this should be ln. So this is equal to ln of exponent b1. So our value for b1 is 1, while the value of b1 here is negative 1. Next, we calculate generate the Taylor-Maclaurin series sum expansion, which is the summation of a times x to the power n, where a, the coefficient, is k to the power n over n factorial. Our value for n is from 0 to infinity. So 0, 1, 2, well, 10 is good enough for infinity. And our value for k is negative 1 or 1. So this is equal to data validation, list of items, negative 1 if it is decay, and positive 1 if it is growth. So negative 1 if it is decay, and positive 1 if it's growth. Next, we generate the Taylor-Maclaurin series sum of the expansion. So array formula, series sum of the x values raised to the power n, where n starts from 0 up to infinity, incremented by 1. And the coefficient will be this range. Now we'll change the line because we will edit this, and this time the expansion will, the line color is red, but the line thickness will be, we'll put that to 8, and the point size will be, we'll reduce it to none, so there's no point size for this. That's good. So the size of the growth will be enlarged as well. So looks like our growth, the point size will be 10 or 14. So that's the size of the growth. Why is there's no line for the growth? There should be line for the growth. The growth will have a line. So it should have a line, a trend line, and should be exponential. And there should be a label. Now we have the label for the growth. So there's the growth and the expansion. So we'll complete the coefficient of the expansion, which is A equal to array formula k to the power n. K raised to the power n divided by, that's k to the power n. For the numerator, the denominator will be factorial. Factorial n. Sure. So if k is negative 1, so the red is a decay. If it is positive 1, the red line is growth. So at negative 1, it is decay. Now we will regress it using logest. Logest data y and data x. And this should be ln. So this is equal to ln of these values. Now if k is 1, meaning growth, the data sets are the same. The regression coefficients of logest are the same. And the red line is on the growth side of the expansion. So these two are the same. So the expansion is growth. The Taylor-Maclaurin series expansion is the exponential growth. If k is negative 1, so the red or the expansion approximates the decay. The data sets are the same. The regression coefficients expansion are also the same. And the trend line equation, they're also the same. The red is on the decaying dataset or the decaying trend line. This completes the use of array formula, SERIESSUM, and LOGEST to generate the expansion of exponential growth and exponential decay.